Alright, time for another DraftPhysics.com. DebatePhysics.com also, but the debate is still kind of thin. So we have 2 minutes and 40 seconds by Ian Gosling responding to my request that they explain why they're so confident. And apparently he's just going to explain that he's confident because of these new dispar experiments with his matchbook cars, and that's all that they need as evidence, and that proves it. So it doesn't really get into why he got into the argument in the first place. It certainly doesn't go anywhere near my counter argument that why is it unreasonable for me to think the theory's garbage when the guy who originated it was wrong. His axiom was overtly wrong. The Charolais-Clay experiment was bogus. And that's all they had. Again, I'm just requesting what in 1850, when they invented the word energy and the idea of kinetic energy, what did they have as evidence? Except the wrong premise of Leibniz and the little fake clay experiment. What did they have besides that? All right, so I'll also just point out, I mean, I have tried to illustrate, argue to you, explain to you why I have my doubts, and you won't respond to any of those points. So a key one, dispar. You're going to talk about dispar. So dispar has multiply proven, many times proven, this premise, that you can have the one mass and the two mass, and these can collide with each other, this having 133 momentum and this having 33, and they can come crashing into each other and only 100 pops out. That's it. So I lose 66. A huge, gigantic, more than 1/3 of the original energy is gone, disappeared. The momentum just disappeared. And I'm supposed to also believe that 100 goes in and I can make 166. Now, I'm saying that that's really, I'm saying that you don't think that that requires pretty extraordinary evidence, not just ordinary evidence, maybe. And I would argue that dispar's evidence isn't even ordinary, frankly. I mean, it's not ordinary up to any, what you'd call scientific standard. It's a bit below that, right? I mean, taking bare frame rates off bad camera angles, off objects you can barely see the shape of in the frames. I mean, come on. Not really up to snuff, is it? So those things exist. I mean, I keep pointing out you kind of have to debunk Brozo's catapult experiment on glass with billiard balls and explain why it's so far off. I mean, it's not even close to 1.4. And you're not doing that, are you? I mean, sincerely, do you think you really are responding to any of that? No. So, in that context, it's just, what do you want me to say? I mean, I've made the counter arguments. I've explained why I'm not too confident that Dispar's experiments are very good. Now, what happened to look, he had the little carbon fiber thing, the lever thing. Why didn't he keep doing those? I mean, when I start mentioning things about the alignment of his gates and this and that, he didn't do any new experiments. Didn't move the launcher a little bit further away, to eliminate my accusation that he was measuring the acceleration of the car, not the actual velocity of the car, because he had the gate way too close to the car, way too close to the lever. Didn't see any follow-up. He just decided to change the agenda, frankly. Why? Those experiments were interesting. Anyway, just like you stopped doing the smashing clay things. Anyway, play this.
A couple of quick points, Gary. I've just watched your video today. Dispar's proving the 1.4.
Okay, so you're using the word proving. I'm just saying, okay, fine. I said it before. Even when he did the lever experiment, he did have the cars going awful fast. I mean, why were they going that fast? You don't need to go that fast. So, what do you think will happen if you slow it down a little bit? What do you think?
More thing, we're getting consistent 1.4s. And you...
Yeah, and that's what you're showing, is that these experiments, I'm just, you're going to basically say what I said, which is when I did the experiment, I didn't get 1.4 right on the nose. I didn't get 2 either. I said that. But I didn't get anywhere near 1.4.
You say, the best I could do was 1.8. Or something like I couldn't get less than 1.6.
Right. Well, that's what he said. So I just put it in the same context. He's saying he's never gotten more than 1.4. Well, and I'm arguing why I never got less than 1.6. So...
and I got a 1.8, something like that. The point I'm making is you can't compare your experiment with this pass. This pass experiment...
Says you. Okay. Yeah, it's just, in my opinion, that's ridiculous. Okay, there's silly little matchbook cars bouncing all over the side in a track. They're stuck inside of a track. They got a gigantic card flapping on them. They got crap glued on top of them. Don't tell me it's a great experiment. Sorry. No sale. He didn't start it without even doing quick releases, for fuck's sake.
Is far superior to what you did with your ball bearings.
Says you. That's what I'll say to that. Mine was much simpler. There was less to go wrong. So, fuck you.
So it's ridiculous to say, oh, well...
No, I think it's ridiculous for you to say his much more complicated experiments are somehow intrinsically superior. No, they're not.
Couldn't get this and I couldn't get that.
Well, he says the same thing, so I should just mock it. I couldn't get anything more than 1.4. Couldn't get any more than 1.4. I'll just mock what he said, okay? Instead of just responding to it with the counter argument. Again, there's clearly experiments that exist, okay? The Mythbusters experiment exists. It's nowhere near 1.4. Clearly, the car's crushing is nowhere near 1.4. So you can go through these and point out, the argument. You won't concede that the water's muddy. I'm saying the water's really muddy. You're saying you can see clearly the truth in it. I'm saying I don't know how you can see that truth so clearly. And then I have the superior context of just pointing out that, well, we know how this all started with bullshit, okay? 4 pounds equals 1 pound. That's bullshit. All right, and the round objects denting clay, that bullshit. So I'm saying I still have the advantage.
In that timing gauge, you didn't have a lot of things set up like this bars did. So that's a rubbish argument for a start.
Well, again, says you. And again, timing gates aren't perfect. So again, if you're not realizing, you're not going to concede that if the car bends or twists or turns, that it's going to make a difference in how it goes through the timing gate. Well, of course it is. It's going to change how thick the card is.
The next thing I want to bring up is this constant bringing up Stephen Bro. Forgive me, Steve, if it's bro or bruv.
Oh, you haven't even figured it out. After 2 years, you haven't figured it out. He told me bro, okay? So I'm just saying, he never said the scruffy bruffy thing to me, all right? He said Stephen Bro. I said to him, how do you pronounce it? I'm calling you bro. And is that correct? And, he said bro. So, fuck you.
Fake thing in my mind, but
I was going like burrow. Okay, it looks like burrow.
With the billiard ball business.
Yeah, it's a very good experiment, frankly. I have to say he well designed the experiment. He created a mechanical release. I don't know if it's exactly a quick release, but at least it's mechanical. There was a lot built into it. He did it first with, I think, some other kind of material, and then he figured out the aluminum worked better. He put a stop on it. He did a lot of things to do the experiment right. And I didn't even realize he used the glass surface, which I'm almost thinking that's what this bar should do. He should just get rid of the stupid plastic tracks and just throw his cars across the glass surface, because it's probably going to be as low friction as you can get. The little plastic wheels won't even bother rolling. The whole thing will be that much better. Maybe even a little oil on the glass.
And you say, well, look, he nearly got twice the velocity. It was very close, you know.
Well, did you watch? Did you look at the experiment? I mean, it was insanely obvious that it certainly wasn't 0.4 faster. I mean, it was insanely faster just watching it. You're sitting there saying, shit, that thing went up and down before. This thing only went one way, and this one went twice the distance at the same time. I mean, it's obvious. The slow motion shows it. The whole thing slow shows it. So what the fuck are you arguing about? It's clearly how it came out. Nowhere close to 1.4.
And I've seen you recently bringing up something about a car going backwards and forwards, a truck. I didn't watch the experiment.
Oh, you didn't watch it, but you're gonna. Oh, okay. Yeah, and there's more than one variable there, right? So that's the problem with that experiment. The fact is, his cars were very low friction, but the point that has to be understood is the wheels were really heavy, so they hold a lot of angular momentum. So that's one part of that experiment that just that's the negative. Okay, and angular momentum doesn't get converted easily. You could understand that if you're rolling something like a ball and you actually roll it into a wall, the problem would be is the ball would actually push down when it hits the surface. It wouldn't push in, it would push down. Now with wheels, that has to happen inside the axle. So the axle has to basically say stop rolling wheels, all right, and it has to convert the spin into pushing forward. And that's where you get a little bit of friction. So it's not ideal to have the linear motion, that is the force, to have a high percentage of it in the rolling of the object. The roll is part of its momentum. Angular momentum is a real problem in these experiments because it breaks the ideal of just saying the object rolls. If I roll something down a ramp, part of its energy is in the angular momentum. It doesn't actually go like 4 times the distance, doesn't actually get you twice the speed, because part of the energy is in the angular momentum of the wheel. So if your wheel is heavy, there's a lot of energy in the rotation of the wheels.
Whatever it was. And you were saying we've got to account for the angular momentum of the wheels. That's taking quite a bit of the energy for the wheels taking. Whatever the energy you put into the truck, the wheels are taking.
Yeah, these are real arguments. I'm sorry, you can mock them and say you don't think so, but I don't think you can do that intelligently. It's the same as your lever argument. It's the same as the pendulums you just made. You just made devices that are very different than a piece of string. Okay, they're very far from the idealization of the swinging pendulum, where we're talking about the weight at the bob at the end. We're really not talking about that anymore. And the same was found out about the catapult. I didn't realize it at first. I thought the catapult would be irrelevant because both objects, it's the same mass, blah, blah, blah. Because I didn't realize that it's going to move at different speeds, and those different speeds mean the catapult itself will have a different amount of the momentum. It holds the momentum. It has it. It takes energy to move the catapult. That energy isn't available anymore. It's a real argument, shithead.
The turn, you're taking a bit of the energy, which would be the linear momentum of the truck. Well, that's the very point, isn't it? That you ignore with Steve's experiment.
No, I didn't ignore it. The fact is, if you look at the experiment, okay, the amount of roll in the other ball is tiny. So you want to tell me how much it is. It's not rolling with the surface. It's just rolling very little. So it's skidding a lot more than it's rolling. Okay, you can see that is quite obvious. So it might make one rotation through the whole experiment. It makes like one rotation, versus the yellow ball, which makes maybe a half a rotation or a quarter rotation. a tiny bit of the total momentum is in the angular rotation of the objects. Their rotation is so minimal. So the argument is bullshit. Just like your, oh, well, the clay fractures is bullshit. Okay, it can be analyzed to be, we can all know, oh, well, that argument that the Play-Doh fractures can be understood to be complete bullshit because it should give you irregular results. It shouldn't give you consistent results. So if you're getting consistent results, you can't blame the fracturing clay. Play-Doh.
Because the half mass skidded, didn't it? It skidded along the surface and it didn't revolve. I'm getting irritated because you do this.
Yeah, you do this. You do this exact thing where you mock quick releases. You mock every kind of thing that's a real physical fact. You didn't want to hear about the fact that, yeah, okay, so, when you're putting a mass in a second mass and, the first mass is already still there. It's already putting weight on a surface. And when you add the second mass, you're just doubling the amount of force, okay, that's being applied. And then, I went through the whole explanation, but you don't want to pay any attention. You're obstinate and belligerent in your will to remain ignorant and stupid of real variables. Sorry. To correct something. Challenging. It's an upside down mouse. Yeah, forces you to really think about it. Anyway.
It didn't revolve, so it had more energy to move faster.
And I said, go ahead, make that argument. There's no way you could make the argument that it would account for the huge difference. So even if you conceded that it rolled actually to the surface, that there was real evidence of real friction, it rolled 3 revolutions. It didn't roll 3 revolutions, but let's just say it did. You'd have to account for how those 3 revolutions was enough momentum, okay, to make a difference.
Whereas the one mass had to revolve, so a lot of the energy went in the angular momentum. So this is a thing. So stop bringing it up, saying we can't.
No, I'm not going to stop bringing it up because it's trivial. Like I said, I looked at you're sitting there just a minute. You didn't even look at the other video. Go analyze the video. Go look at the Stephen Bro video and count how many times the billiard ball rotates, and you'll notice, oh, it doesn't. It's like less than 1 rotation.
Explain why Steve's experiment nearly got 2.
Well, it's not.
Anyway, that'll do for now, I think. There's plenty more. I'll be keeping a check on your...
I don't know whether that's his fault or YouTube. Yeah, that's not very good ending. Let's try from there, see if it'll play. No, it won't. Interesting. Yeah, I don't know. Computers. Yeah,
Explain why Steve's experiment nearly got 2.
I don't know why it just jumped to a new window.
Anyway, that'll do for now, I think. There's plenty more. I'll be keeping a check on you, honestly.
Yeah, whatever. I mean, I'm really not interested in 2-minute and 40-minute explanations of anything. So if you can't do a little better than that, I don't really think you're doing physics. I mean, 5 minutes is bad enough. But, physics requires an explanation. You do have to draw something now and then and explain how it's mechanically working. And if you're really not willing to do that, I mean, this trite little crap doesn't mean anything.
The collision experiments, I watched them back, and they weren't bad, were they? Pretty well shows that the half mass is knocking back the full mass.
I don't know how the fuck you could interpret your experiment as revealing anything. The amount of movement is so minor, it's incredible how much energy is lost, not preserved. It's not an elastic collision. I don't know how you could see it as elastic. I don't see how you could see how anything could be measured out of it, because obviously most of the energy was converted into motion in sideways directions and sound and all that kind of crap, because obviously the objects didn't do much moving after the collision. So I don't know what the fuck you're talking about there.
Yeah.
Fuck you. Not if I see you first. Oh, frozen. Well, damn it. This computer really should be okay. And it's not. Alright, so, what do I do now? So it stopped recording. I guess an option is I could hit this button. Yeah, I could go ahead and hit this button and see what happens. Oh yeah, wait, it's what the hell button did I have? L? Is that what does it? I had some key I was using.